I'll also answer some of these in the discussion because actually these are some really good questions. All right, let's get started again. All right. Oops. Full screen. Kind of full screen. That's okay. All right. So thanks so much for joining us today. So I'm going to be sharing all the information I have about 3D printing in a very short period with you. It's going to go over more breadth and depth. So we're going to cover a lot of different technologies and what you can do with 3D printing. So quickly about me. So my name is Adalyn. I'm a senior customer success representative at Mosaic Manufacturing. We at Mosaic are a digital 3D printing company. So we create technology for 3D printers that includes hardware products, software for multi-material printing. So being able to upgrade your existing 3D printer to use more than one material. So really quickly, what we're going to go over are the different 3D printing technologies, the basics of 3D printing and how it works, the different applications, and then ways to pursue 3D printing as a hobby or career. So just some things to think about when it comes to 3D printing, maybe things that have occurred in your own personal life. So have you ever wanted to maybe design and build your own products or your own projects, but couldn't find the exact designs you needed online? Have you ever maybe broken something and needed a quick fix or replacement, but couldn't find it as well? Or maybe have you ever wanted to really buy something that was useful or cool, but just couldn't justify the price or wanted to wait for shipping? So if you've encountered similar problems or issues in your personal life, these are some ways that 3D printing can be used. So 3D printing is known as additive manufacturing. This is a process in which an object is built by forming material layer by layer, as opposed to cutting away material. And the manufactured object is known as a part. So there are a lot of different types of 3D printing I'll go over quickly before diving deep into fused filament fabrication, which is the main type of 3D printing that I work with. So 3D printing can be done with polymers or metals. Polymers can be further classified into thermoplastics and thermosets. So your thermoplastics are like your 3D printing filament that can be melted, formed into a shape, and then reheated again. Whereas thermosets are like your UV liquid resins that cannot be remade into shapes after they've already been heated. And for 3D printing metal, those come often in basically a powder form. So we're going to start with SLS, which is selective laser sintering. This is a process where a laser is used to fuse polymer powders together, also layer by layer. It's used to produce strong functional parts, and it has a really nice consistent surface finish. And what cool thing about it is you can stack parts on top of each other or beside each other to maximize the build volume. And it uses materials such as polyamide or nylon to really achieve that strength. Some downsides to the side of 3D printing are that the machines themselves can be very expensive and the lead times can be long. Moving into SLA or stereolithography, this is your liquid resin 3D printing, which you might have seen online. So basically a UV laser light cures the liquid resin also layer by layer. With SLA, you have a wide range of materials to choose from, and you can achieve a very fine details with very few surface defects. It's also great for basically prototyping for these reasons because of how fine the details are. But they're not as good for end-use parts because the material tends to degrade with sunlight. And then finally, moving into metal 3D printing or direct metal laser sintering. So it's similar to SLS, where a laser is used to fuse powder together, but in this case, we're using metal powder. So the metal powder can basically print aluminum parts, stainless steel, titanium, gold, platinum, and silver. So here, what's happening is that the powder is not actually melted, but they're fusing together at a molecular level to bond and stay together. So this method is great for cases where you need very like highly customized geometry for metal. But a downside to this is that the material costs are very high. And then there are other methods of 3D printing, such as binder jetting and material jetting. This is where a liquid binding agent is dropped onto that same powder, or having the material dropped and then using a UV light to cure as it goes. So there's a lot of different types of 3D printing technologies available, but the common theme here is that whether it be done with laser sintering or UV light, or with material extrusion, which we'll talk about later, is that we're doing everything layer by layer to produce a part. So these are just some of the different 3D printing technologies in action. So this is SLA, or the liquid 3D printing. So there's the vat of resin, and then it eventually lifts it up as it goes. So you can see how nicely detailed that is with the liquid UV resin that eventually turns into a solid. And then this is quickly how metal 3D printing works. So that's the laser sintering in action. So that's the same thing for SLS. So quickly, you can really see how 3D printing can be used for both the prototyping side as well as producing the actual end-use parts that you're going to use. So that brings us to fused filament fabrication, which is the type of 3D printing we do at Mosaic. So this is the process of building an object layer by layer, but with material extrusion. And this type of 3D printing is more widely adaptive and relatively easy to get into. So basically in this method, plastics are melted and then driven through a nozzle, and then the material is deposited in predetermined paths that eventually develop the part. So you can kind of imagine this being like a hot glue gun, but you can decide the hot glue gun's movements and also when to stop or start using the glue. And since this type of 3D printing is more affordable, it's great for prototyping, testing out designs, and also printing everyday functional parts. So how does it work exactly? So everything starts with a model, whether it's something you design yourself or download from repositories such as Thingiverse or My Mini Factory. So here we have basically just the geometry of the model. And these files can be OBJ, STL, or 3MF. That model needs to get recognized by the printer, and that's where we go into slicing. So a slicer is a software program that turns the model into what are known as toolpaths that are recognized by the 3D printer in terms of where it has to go to deposit material. So a common file output for slicing is a G-code file. That's what's going to be recognized by the printer. And then from there, you get to decide what materials you'd like to print with, and we'll go deeper into this very soon. So the printing material comes in what's known as filament or a spool, and it comes in a lot of different finishes and colors. Once that material is loaded into your printer, it is melted and basically pushed through the nozzle like we mentioned. And then eventually the part will begin to build line by line, layer by layer, until it's complete. So quickly going over some of the materials you can print with, they come in the form of a spool, like you can see here. So PLA is commonly used and comes in a wide range of colors, hardnesses, and finishes. They're made with sometimes biodegradable materials such as cornstarch or sugarcane, but they do take a long time to really break down naturally. And they can be recycled into or extruded into new materials. PETG is PET with glycol. PET is the same material that is used for water bottles. The glycol crystallizes the PET and basically makes it more strong for 3D printing. It's durable and water resistant, and during the beginning of the pandemic, many were using this material to print headbands for face shields. TPU is a flexible material that's great for wearable applications, such as phone cases, wristbands, that sort of thing. And then PVA is a water-soluble material that washes away with water. It's used often as a support structure, so that way you don't have to worry about snipping it off or having to file it off. And then lastly, ABS is a very strong and durable material that allows you to print electronic cases. It's used in automotive parts and even some consumer-grade electronics and gadgets. Lego, interestingly enough, are made from ABS. And this is just sort of some introductory materials of what you'd be exposed to if you get started with 3D printing, but there are also industrial materials that can be printed under the right conditions. And this is quickly just some examples of the different like colors and finishes you can get in 3D printing. So you have composites where things like wood powder or stone powder are mixed with PLA to get this sort of natural finish, but still being able to melt them for 3D printing. You can get some really nice like shiny metallic or glittery and iridescent finishes as well. And there's also some exotic filament such as glow in the dark or UV filament that reacts to sunlight and changes color. And then here we have some multi-material examples as well. So this is TPU being printed in multiple colors, and we see also this type of 3D printing in action and how we're developing a part layer by extruding material. And then here you get to see its squishy qualities. And then to come back to that PVA material I was talking about earlier. Oops, sorry. Okay, so this dodecahedron is printed in PLA, and then this white stuff is the PVA I was talking about. So that's going to wash away in water. And then after the PVA washes away, you're left with actually just the PLA. And so with this, you can actually achieve really complex geometries in your 3D printing. All right. Those are just some examples of the materials that you can print with. All right, so what can you do with 3D printing? So when you're first getting started with 3D printing, you'll find that some of the first things you'll print are decorative or functional. So you can find things for your home and your workspace, such as vases, desk organizers, storage containers, phone accessories, and more. That really honestly only scratches the surface. Like your imagination really is the limit when it comes to what you want to 3D print or whatever it is you're really looking for. So what makes 3D printing fun is the level of customization and personality you can add to the things you can print. So instead of buying something really generic, you can really make it your own through the colors you choose and some of the technology we have available today for multi-material printing. As you start to maybe gain some CAD and design skills, you can even start producing parts for your own project. So for example, this here on the left is a casing for a Raspberry Pi and screen and keyboard. So it's basically its own little standalone computer. And then with 3D printing, basically, and these CAD skills, you can start really seeing your visions come to life. Some other ideas for 3D printing, you could also maybe start your own small business, creating custom parts for other people, or even having your own store where your own designs like these ones would be sold. So these are just some ideas. The world of 3D printing is honestly really, really big. The sky's the limit, and we'll get to talk a bit also about how 3D printing is used to solve problems. So quickly summarizing some worldwide applications across different fields and industries. So in the medical field, we already see 3D bioprinting being used to create tissues and organs that are very similar to the real thing. We also see organizations like Enable producing prosthetics, and 3D printing can be used with medical imaging to basically bring these CT scans to life. Moving into construction and architecture, 3D printing is also used to produce fixtures for houses as they're being built and the houses themselves. So there's a company out in the US called Icon 3D that are basically 3D printing houses with a giant 3D printer that extrudes cement. So very similar to the printing we've already seen already earlier, but if you can imagine that being really big and then extruding cement, that's pretty much how people are 3D printing houses today. And then for like architecture and interior design projects, they can be used to visually exemplify the exterior of a building or even the interior and the floor layout. And then, of course, moving into conventional manufacturing, 3D printing is already being used in aerospace application as well as the automotive industry for end-use parts. In the textiles and wearables spaces, we're seeing places, companies like Nike and Under Armour incorporating 3D printing into their products. And you can also see how 3D printing can be used to achieve fabric-like quality. So the emblems on this jersey were actually 3D printed. And then, of course, 3D printing is being leveraged by higher education. So whether it be for research projects or design projects, you see universities also incorporating 3D printing in their curriculum to help bring projects to life. So a common theme across all of these different applications that we talked today is the idea of being able to take an idea or even a digital file that otherwise would have just been 2D and then bringing it to your real space. So by basically being able to visually and tacitly communicate properties such as geometry and color, we're able to bring these ideas to life. We can start to iterate on those designs, test them, and then bring a final product to market sooner, or even just for our own needs. So what does the future of 3D printing look like? So we can only predict what will happen in the next 5-10 years, but these are some areas where we see a lot of potential impact. So the first one being, we'll see more of this desktop 3D printing actually brought to the factory floor. This is because this technology is actually fairly low cost and can still produce higher volumes, and it can be an alternative to some of the expensive industrial systems we see today. And this is going to be possible as automation gets developed and improved. And by basically taking a lot of the grunt work involved with 3D printing, such as removing parts or the post-processing, we can have smarter systems that require less human intervention. So for example, at Mosaic, where I currently work, we're working on a system that has basically 4 big 3D printers managed by like a robotic arm. So that way the print changes are done by that system, as opposed to having someone come in and do it manually. Like quickly, we'll play a video. So that's the robotic arm. And so instead of having someone come in and do those bed changes, we'll have this system take care of it. And it's also managed by like an IoT system where you can monitor the prints remotely. And there's also big leaps being made on the software side of things. So with artificial intelligence and machine learning, we're seeing CAD processes become a lot smarter as well. So for example, Autodesk introduced the idea of like generative design through CAD. So by having a set of parameters as inputs, the computer will actually generate designs for you. And then you can select the one that really works for you. So that's the example of generative design. And then, of course, there's also something that's emerging, but still very early, but the implications for it are really big. So the idea of 4D printing. So this is where 3D prints are basically reacting to stimuli such as heat or water, and then they basically start to change their shape or morph into something else. And the implications for this are that you can have self-assembling structures in places that we humans can't reach that easily, like in space or underwater. So we can start to kind of envision a future of what that could look like. So these are projects done out of MIT's self-assembly lab. You can see how underwater these structures start to change shape all completely on their own because of the materials that they are printed with. So I don't want to get too much into whether you want to pursue it as a hobby or career, because there's no set path really. I think having an open mind and staying curious about a lot of different things will help you if you want to get into a career on 3D printing. So even studying things like Internet of Things, physical computing with Arduino or Raspberry Pi, 3D modeling, even UX and product design, and other hobbies such as contributing to like open source projects, even drones or 3D scanning. There are all these peripheral areas of interest that all relate to 3D printing in one way. So yes, there are your traditional STEM paths, getting into engineering, getting into software development. But I think having curiosity and learning more about different projects and hobbies all in a way relate to 3D printing. And it also doesn't hurt to have some design skills in 3D modeling, learning about industrial design. It really is an open-ended exploration, and I guess depending on what kind of role you see yourself doing at a 3D printing company, that would decide sort of maybe what courses you take or what workshops you take. But it's really easy just to get started with 3D printing by being a generalist and just having an open mind and learning a lot about different things. So I think you all might have caught the end of my demo from that last presentation, but I'll quickly show it again once more. So we'll do the 3D printing process sort of together. So like we mentioned before, everything starts with a model. So whether you design it yourself or find it off a website like Thingiverse or My Mini Factory. So here we can see it in its geometric sort of form. So just the shape of it. And then once we have our model, we upload it to a slicer. The slicer will turn this model into something that the 3D printer can recognize. So this becomes a geometric shape. It turns from a geometric shape into something the printer recognizes in terms of paths it needs to move and extrude filament. So this yellow section you see in the middle, that's your infill. And then you also have perimeters, and all these settings can be adjusted in the slicer basically depending on what you're looking for. Like, are you looking for something that needs to be strong, or is it something that's just going to be displayed? So you can make a lot of tweaks depending on what you're looking to use it with. And you can also see, as a slicer does, everything is done layer by layer. So you can even start to see the little paths in between to develop the part. So we go from seeing something that's basically polygons and triangles to paths that the printer has to move into. And then really quickly, here is a print in action that I have going on at the moment. So if you can take a look quickly at my camera, there is a 3D print going on of the same Squirtle thing that I'm printing. This has been going on for a couple hours now. It's actually about halfway done. So you can see the print head. That's basically the hot end of the printer. The filament is coming in through the top and then eventually deposited through the nozzle at the bottom. And I think that's it. So just wanted to say thank you to the Innovire team, everyone for attending. And yeah, if I'll be in the Discord chat to answer some of the questions that were dropped in the chat here.
Yeah, thank you for coming today as a speaker, and yeah.
Cool, thanks for having me.
So I believe now you guys will go to the YouTube panel. So I'll see you all in the YouTube live stream.
Awesome, thanks guys.